So 12.4 the expected values, fair price, average winnings, what's your long run value? The sigma notation again is talking about sum. So when you get into pre-calcs, we use sigma notation when we add up sequences, arithmetic, geometric, all that stuff. So basically what this is telling you is find the sum of some event, whatever it is, times its probability. And so when you look at a table, the x's here represent, you're maybe playing a game and you win $2, you win $6, you win $0. The probabilities are listed in the table. You have a 0.4 chance of winning $2, you have a 0.3 chance of winning $6, and you have a 0.3 chance of winning $0. When you multiply those together, it turns out to be 80 cents, $1.80, and $0. And so my expected value is going to be $2.60 every time I play this game. Now, if I have to pay $1 to play that game, that would be pretty good, right? I pay $1, I'm expecting to win $2.60 back. But if I have to spend $5 to play the game, and I expect to get $2.60 back, that would not be good. That's how this works.
Doesn't there be like a certain probability to win in Vegas in order to...
All right, so this particular one is your grandpa has for your birthday this game that he plays with you. So every year he takes his wallet, opens it up, and you get to close your eyes and draw one of the bills out of there. So on his birthday, you peek in the wallet and you see there are 8 bills. There are 2 $1 bills, 3 $5 bills, 2 $10 bills, and 1 $20 bill. What is your expected value of your birthday present? So I could win $1, right? I could get a $5 bill. I could get a $10 bill. And I could get a $20 bill. So then what we're going to do is multiply by the probability. So what's the probability that I get a $1 bill? 2 $1 bills, so that's times 2 over 8. I'm not going to worry about reducing that fraction because the 2 over 8, or if you reduce to 1/4, that's not the point of the problem. What's the probability of getting a $5 bill? So we'll multiply by 3 out of 8. $10 bill? 2. So 2 out of 8. And 20. 1 out of 8. So you're going to go to your calculator. You're going to multiply all those together. And then add them up. So on a calculator, you would do a $1 bill times 2 divided by 8. Then I can add to that the $5 bill times 3 divided by 8. The $10 bill times, is it 2?
Yep.
2 divided by 8 again. Or the $20 bill times 1 divided by 8. And it looks like I'm getting an expected value of about $7.13. Now, is it possible to get $7.13 for my birthday? No, but that's the expected value. So if Grandpa plays this game every year with you, right, from the time you're 1 to the time you're 18, let's say at graduation, yeah, some years you're only going to get $1 from him. Some years you'll get $20. But mathematically, theoretically, he's basically giving you $7 every year. And the longer you play the game, the closer your number will get to $7. The average would be $7.13 every year. In roulette, a wheel and ball spin around in opposite directions. So the wheel's going this way, they send the ball going that way. When they stop, ball starts bouncing, boom, it'll land in a slot. It has an equal chance of landing in any one of the slots. Roulette wheels have 18 red slots, 18 black slots, 2 green slots. Suppose a player bets on red, which is just an even money bet. So if you bet $2, you're gonna win $2 back. So you get your money plus $2. The player, if the ball lands in a red slot, the player wins $2. The price to play is $1. Is $1 a fair price for playing roulette? So, how many slots are on the wheel?
38.
Right? There are 38 different little slots or numbers. The black ones, the red ones, and the green ones. There are 38 of them. So in this particular game, the player is betting on red. So the player can win $2 for betting on red. They can win $0 for betting, or if it would land on everything else, right? So what's the probability that it's going to land on a red number? 18 out of 38. 0, what's the probability for 0? The other 20, so 20 out of 38. All we have to do is multiply those two and add them up to get our expected value. So we had 18 divided by 38 times $2. I win. Do I really need to do this one? I mean, 0 times, it doesn't really matter. You're winning $0, right? So $0 times 20 divided by 38. So if you really have to type it in, go ahead if you feel the need, but 0 is going to be 0. So I expect to win 95 cents. Is this a fair game? Absolutely not. Absolutely not. Because my expected value is less than what I'm paying to participate. Right? So you can write kind of whatever reason you want. It's not fair because I'm spending $1, but I'm only expecting to win 95 cents back. Now when you go buy things, we buy things because they're great value. I walk into the store, the pair of shoes are normally $150 and they're on the clearance rack for 20 bucks. Right? I don't really need them, but it's such a great value, I'm going to buy them. This is not such a great value. Everything you do with gambling is set up this way. Now, can somebody win multiple times in a row?
Yeah.
And then they have fun, and they think this is such a great deal. But overall, like if you continue to play the rest of your life, you made this bet 100 times per day, every day for the rest of your life, what's going to happen? You're going to lose 5% of your money. You're just going to throw it away. On every 1,000 bets of $1 on red, how much money does a casino expect to make? So if they have a bunch of people playing in a day and they make the same bet, $1 on red, for 1,000 bets, how much does the casino expect to make?
$50.
1,000 bets times $1 is $1,000. The casino is expecting to take how much of that? Because the expected value is 0.95 times 1,000. You know, oops, I forgot my $1. So how much do they expect to take? You could multiply that by the 5%, the 0.05, right? The player expects, you know, to take 95% back, 5%, or you could say the player, the casino for every 1,000 is expecting to take 0.05 of a dollar, and what is that? Move your decimal 3 times. $50, right? Now, if you've ever gone to a casino, everywhere you go, they work fast. Everything happens fast, quick. Why?
They don't want.
People have more fun when things are happening, and then also the faster they can go, the faster they take your money.
And people don't think about it.
Right. At the Meadowbrook Carnival, Renee is trying to get Leroy to play a game she has invented. Leroy would spin the spinner and get the gift certificate worth the indicated amount. The school charges $5 to play the game. So what I'm going to do is pause the game, or pause the video. You guys are going to look at answering A, B, C, D, E with somebody sitting near you. Now, this is charitable gambling, right? Which tends to be a little bit different. People don't care if they lose, right? Because the money goes to, you know, a good cause or whatever. So, but answer the questions based on the theoretical probabilities. All right. That's what my work would look like. I'm making just a table kind of like we've been doing. I expect to win $0, $5, $6, $7. They all have a 1/4 or 0.25 probability. So when you multiply them, those are the numbers you're getting. And then basically you just have to add them up. So on the exam, you want to write this stuff down somehow. Show me what you added up. So what's our expected value? The fair price, they call it. $4.50. How much are you spending on the game? $5. So is it a fair game? No.
Not really.
But when you look at the wheel, I mean, the spinner, it's like, oh, you know, I have 3 chances that I'm at least going to get my money back. So yeah, that's a great deal. But overall, they're going to make 50 cents every time somebody plays. So at a charitable event, it's probably not a bad thing. So if we can get Leroy to spend or spin it 100 times, we expect to win $50 off of him. And how much does he have to spend to play those 100 games? You know, $500. So that's a pretty good deal. Now, doing a problem like this, the last one is design a spinner that would make make $5 a fair price to charge to play, and be able to explain why your spinner has a fair price. Did anybody design one?
I did.
Okay, Rose, let's start with you. Did you do that? Okay, what did you put in there? Oh, you did, okay.
I don't think that's fair.
Is that fair? What's your expected value? To be fair, you'd have had to have.
It would have to add.
You would have to have 5, 5, 5,
5.
and 5. Because right now your expected value is 1/4 of 5, which is $1.25 here, 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 and then 0 there. So when you add them up, it's only $3.75.
Yours is worse, bro.
Yeah, yours is worse. You're really, your charitable gambling is not what.
I said, 6, 7, 2, or 5, 2.
Why does that work?
Because it adds up to 20 if you divide 20 by 4 every time. But it should have.
So what's happening mathematically is you're multiplying every event by its probability, right? Every event by its probability. So why not think of it as, well, if the spinner has 4 equal parts, the probability is 0.25 of every one. So you could literally factor the probability of each event happening, pull it out, and so whatever money amounts you put on the spinner better add up to $20 because 1/4 or 0.25 of all the amounts has to be $5. So there are other spinners you can make. There are some examples. Again, this one would not be very much fun to play, right?
I want.
Here's $5, give me my 5 back, right? This one maybe a little more exciting because you could win up to 10. Stuff like that, 1, 2, 3, and then a 14, So,
We could have 0, 0, 0, and 20.
Yeah.
That'd be pretty fun too.
are these the last 2 questions?
Yeah.
Or do you guys have
We have 3.
C? There it is.
Yeah.
Alright. Last question, school raffle has the following prizes. There's a microwave oven that costs $400. And there's the chance to win it. There's a video game that costs $100, and the chance is 3 out of 500. And a bike that costs $175, and you have a 1 in 1,000 chance. Exactly 2,000 tickets will be sold. I want you to calculate what's a fair ticket price. If the tickets sell for $2, how much profit would the school expect to make? And then what is the probability that you win nothing? So you're going to answer those 3 questions very quickly again. Do you want me to walk you through it, or do you want to
Wait, I have a question.
do it on your own? Do you like time to do it on your own?
Yeah.
Yeah.
Okay, you do it on your own, and we'll go over the answers.
I have a question.
You just did it the opposite way around.
Now, some of you, if you want, can get real fancy with your calculator, and you can put stuff in L1 and L2, and then make the calculator do the work. There are very few calculations that you're making, so I think it's just as easy to say, all right, my values in this problem are $400, $100, $175. So the microwave supposedly is a $400 microwave. The probability of winning that is 1 in 2,000, and I get a 0.2. $100, that's the game, the video game. There's a 3 in 500 probability of winning that, which is 0.6. And a $175 bike, 1 in 1,000, that's 0.175. So if I add those 3, this is my expected value. That is my expected value. It's also the fair price, they call it, right? So if you want to kind of break even, you should sell all the tickets for $97, $98, or 97 cents or 98 cents. Probably 98 cents would be better, they're not losing the money. So what they're telling you now is the tickets sell for $2. So overall, the ticket sells for $2. I take away the $97 and a half cent, 97 cents, 97 and a half cents. So really what they're doing is they're making about $1 off of every raffle ticket that they're selling. So now if we multiply that $1 that they're making times the 2,000 tickets that we've sold, it shows us that per ticket profit, they're going to end up with about $2,000, $50. What is the probability that you win nothing? So what you can do is just add up the chances that you win something. So right here, those are the chances that I win something, these three numbers, and you say 1 minus whatever their sum is. And so I have about a 99.25% chance of winning nothing.